My name is Mike Logsdon. I'm a lead composite technician at DAS. Today we're working on an outboard trailing edge from an elevator off a Gulfstream G5, 1" by ½ puncture that went through the trailing edge skin of the elevator. There was a through puncture on this skin, so we removed it from the assembly, routed the hole out so the edges were clean, and did a scarf repair. And on the inside, we laid up one layer that was about 1 inch wider than the hole, put a fill ply in the middle, and then stepped it out on the outside to give it a little bit more rigidity. We put a repair ply on the inside, a filler where we routed it out, and then we stepped out the skin on the outside, like taper sanded it smooth so we could add more material without adding any additional thickness. And then once that's cured, you're going to want to come out and fair sand it, make sure you don't have any lifted edges. For this repair in particular, tools that are essential are going to be your sanding tools like a DA, die grinder, a rotary file to clean out the puncture. We're going to want clamps to make sure we get good pressure on the wet layup once it's applied to the part. And we're going to want our PPE, like our respirator. One challenge that we faced with this repair was figuring out how to get good pressure on the wet layup once we got it down. The part's too fragile to bag and it could crush itself under vacuum. So what we ended up doing was making a wedge that fit on the inside snug so we could use clamps and a call plate on the outside. So now I just got to mix some epoxy up. So everything we mix in here is by ratio. So this particular epoxy is 100/30, but I don't need quite that much, so I'm going to split the ratio 50/15. Yeah, so this will give it like some structural properties. So as you could see, like when I was cutting it, the carbon fiber is pretty flimsy on its own, but it combined with the epoxy, it's pretty strong. So make sure it's all combined really well. This is how we impregnate the fabric. We do primarily wet layups here inside this plastic film. Close it up. And wet it out. Just push the epoxy through the weave. Now, when you're getting ready to lay fabric on this, you kind of want to wet the part out a little bit too. Spread a thin layer over it. So I like to cut the edges off. Let's cut a little bit more than I need so I can make sure we don't get any of this frayed material in there. We want the weave to be intact so the part's strong. When you're looking at it, you can see the way the weave runs. If you look at the part, you can see the way that it's running. Anytime you're laying material up, you want a 45-degree offset. Kind of helps the part, it makes the part stronger. It's important to repair versus replace in cases like this because of cost. It'd be substantially more expensive to replace this elevator than it would be to perform this repair. We ensure parts meet standards before they leave here by strictly adhering to our quality processes in the building. We document everything that comes off. We document everything that goes back on. In this particular instance, we're using mechanical pressure versus vacuum pressure. Because of how thin this skin is, you can see if we tried to bag it, we would probably damage the part. So I've got a wedge prepared that matches the inside of this skin. Place that in there. Some release film at the top. And this is a call plate. It'll help it stay flat where we want it. Once we finish the composite repair, it'll get a QA inspection before we throw it together. It'll get a follow-on QA inspection final, and then we'll transfer it over to paint. It's a good feeling knowing that the work we do here keeps airplanes in the sky. It's fun work, and it's always nice when you can meet a tight turnaround time. It makes the customer happy. So you get it all set up. I like to go low heat first. You want to check your temperature with a pyrometer periodically to make sure you don't get too high. You don't want to burn the epoxy. So it'll be about an hour at 150 degrees from the lamp. If you don't use the lamp, it could take up to 7 days for a total cure. There's other curing options too. You can throw it in an oven, an autoclave. You can use a hot bonder. For small repairs like this, it's pretty easy to use a lamp. This is just a small example of the composite capabilities we have here at DAS.